Next, we are going to see a special type of metric on the set of real numbers. Here, the metric is defined to be in this form. If the numbers are different, then the metric is defined to be the sum of absolute values of the numbers. And if they are same, it is defined to be 0. Now, the first condition to check whether this is a metric or not is the non-negativity, for which just look at here. This is a non-negative quantity and this is a non-negative quantity and this is 0. In all the cases, what we have is, we have this. And this mapping is defined in such a way that this has to be 0 only if x and y are same, and if x and y are same, then the mapping has to be 0. Therefore, what we have is d of xy is 0 if and only if x and y are same. Next, to prove the second one, we know that absolute of x plus absolute of y is same as that of absolute of y plus absolute of x. This gives you that d of xy is same as d of yx. Next, to prove the triangle inequality, let us consider the cases. That is, let us have this in one side, let us have this in another side. What are the possible values for this case? This will be either absolute of x plus absolute of y or 0. The similar goes here too. Absolute of x plus absolute of z are 0. Absolute of z plus absolute of y, sorry, it's y here, 0. Now, let us have the 4 different cases. That is, if x is same as z and z is same as y. Okay, and if x is same as z and z is different from y, then x and z are different and z and y are different, and all these values are different, which means x and z are different and z and y are different. Now, what is going to happen here? If all the entries are same, then we will have 0 here, 0 plus 0 here. And here we have taken x and z are same and z and y are different, which means here we will have z plus y, here we will have 0. See, from this, here we can come to the conclusion that here we will have absolute of x plus y. But here it is assumed to be x and z are same, which means this is nothing but absolute of x plus absolute of y. Okay, the same is applied here, but here what we will have absolute of x plus absolute of z, which is going to be absolute of x plus absolute of y because of this, and here we will have 0, and here it is going to be absolute of x plus absolute of y. Okay, in the last case, x is different from z and z is different from y, which means here we will have absolute of x plus absolute of z, and here absolute of z plus absolute of y. This is what we are going to have. But we do not have any guarantee that x and y are different. Okay, they may be same or they may be different. If they are same, we will have 0. If they are different, then we will have absolute of x plus absolute of y. Okay, now in the first case, what we have is this. We have an equality. Okay. In the second, we have this. Absolute of x plus y is 0 plus absolute of x plus absolute of y. Okay. In the third, we are having this. The same. Absolute of x plus y. Absolute of x plus absolute of y is equated to that itself. Now, in these 3 cases, we have a equality. Come to the fourth case. Here, what we have is, let me erase this part and let me make use of this space. Sorry, this is d of x comma z. Okay. Here what we have, either 0 is to be equated with absolute of x plus absolute of z plus absolute of z plus absolute of y, and absolute of x plus absolute of y. Here we have this quantity. Okay. All these quantities are non-negative. Therefore, this will be bigger than or equal 0. And here, what is going to happen? Okay, sorry. Okay, this may be, we have assumed these are different, right? So this is going to happen. This quantity must be bigger than 0. And here, you see, this is that. There is something extra in the right hand side. Therefore, we will have this. So here, in all these expressions, we have equal, here less than or equals. Combining all these things, we can conclude that d of x comma y is less than or equals d of x comma z plus d of z comma y, and this is true for all x, y, z in the real life. And this concludes that this is a metric defined on the set of real. Thank you.